Okay, so here we just did number 2 and we're moving on to independent events, okay, on your note. I know it's a bit tight to squeeze. If you want to, you could squeeze your answer in there, but it's tight. But if you want to, you can always get a different piece of paper and write it on another piece of paper. So we're going to look at independent events. Okay, the occurrence of one event has no effect on the occurrence of another. To find the probability of independent events, you multiply. Hint, you look for the word and in the question. And if you see and, then you multiply the two probabilities. If we go back in these questions, we saw the word or, right? Or, so or, and there was, okay, or, those were all adding. Now we have the word and, there's the key, and, somewhere in the question, then you're going to multiply the two probabilities. Again, this is a bit of a review. We've done this before. So let's take a look here. Okay, the probability that a student at St. Stephen's likes ice cream is 75%. A little bit low, I think more than that, but that's the probability I found. Okay, doing my surveys, going around, some people didn't want any ice cream. Oh, I'm kidding. I didn't do any surveys, but probably 75% like ice cream. The probability that a student likes to play baseball or basketball, not baseball, basketball is 20%. So let's see what it says. Find the probability. So find P, which is in a bracket. The student at St. Stephen's likes ice cream and basketball. So there's the key word, and. So we're going to multiply two probabilities. So let's find the probability that they like ice cream. So if they like ice cream, it's 75%. So you got 75%. Okay. If they like basketball, it's 20%. So if they like this and this, you multiply. Now you just don't multiply percents like this. You have to turn them into a decimal. Well, how do you do that? Hopefully most of you know that you just divide by 100. So you take 75 divided by 100. Okay, it's 0.75. You kind of move the decimal over twice. So 0.75 times, and this one's 0.20 or 0.20. And then you multiply the two numbers. So 0.75 times 0.2, 15.15. See, I get an answer, 0.15. I multiply the two, and hopefully you're just doing this at the same time as me. Okay, how do I turn that? You multiply it by 100, and you turn that to 15%. So 15% of the students, okay, like ice cream and basketball. Let's try, that was question 3. Let's go to question 4. So we'll bring up question 4 here. Let's read it, and I'll do it on the bottom. A coin is flipped. A coin is flipped and turns up head. What is the probability that the second flip will also turn up heads? So the first coin is flipped, it turns up heads. What's the probability of the second? Well, it makes no difference. The second flip is independent from the first. So there's still a 1/2 or a 50% chance that the next coin will turn up heads. Okay, still the exact same, 50%. Let's look at the next one, B. Okay, a coin is flipped 4 times, and every time it keeps turning up heads, and you're just thinking, okay, what is the probability that the 5th trial will be heads? And you're thinking, oh, it can't be heads. It can't be. Well, the probability still, okay, for B, is still that the next coin is still 50%. Still 1/2. It doesn't matter how many times the head is turned at the beginning. Okay? So now the difference, if you do 100 times, and 100 times it turns up head, the next one's also, I'd be checking the coin to make sure it's not a two-sided head coin, but if there's a head and a tail on both sides, then it's still a 50% chance. Now C here, C part. I'll fold this paper, so C, on C part here, and I'll write here, C. Find the probability of tossing 5 heads in a row. So if you want to toss a head, another head, and another 5 times in a row, well, it's a half times a half times a half times a half times a half. 5 times. 1, 2, 3, 4, 5. So if you want, it's 0.5 to the exponent 1, 2, 3, 4, 5. 0.5, because when you do that many times, you can write the exponent. See what that is. 0.5 to the exponent 5. Let's get our calculator out. 0.5 to the exponent 5. 0.03125. Okay, times 100. 3. Now, how do we round this? So we round this 3.13%. So if you take a look, that 5 makes that a 3. So 2 decimal places is 3.13%. Okay, let's go on. That was question 4C. Let's go on to question 5. Okay. A die is rolled and a coin is flipped. What is the probability of an even number being rolled and a tail being flipped? There's that magic word, and. So we know right away it's a multiply question. So we know that two are going to be multiplied. So a die is rolled and a coin is, what is an even number? So let's see. 2, 4, 6. There are 3 even numbers out of 6. Okay. And a tail appears. So if a coin's tossed, there's 1 out of 2 tails. You just multiply the numbers. So if you multiply, and I've seen some weird stuff on multiplication, but you just multiply the top and the bottom. You can use your calculator too. But this is 3 over 12. Oh, that's like a quarter. So I'm going to use my fancy math here. That's 1 quarter or 0.25 or 25% for those of you. Okay. Well, if you don't believe me, okay, you're going to go, well, let's do this the other way. 3 divided by 6 times 1 divided by 2 equals 0.25 times 100. There's 25%. Question 5. What I would like you to do right now is do questions 6 to 8. Okay, so you can right now in the next video, I'll put up questions 6 to 8. Okay, so do questions 6 to 8. And I'm going to put them up quick. Okay, I'm going to put them up really quick. Okay, so I'm not going to take my time. So they're very similar to the ones we just did. Okay, and then we'll go and do number 9 after. Okay, so right now, go and do 6 to 8 and get the next video ready. And then play the next video. Give about 5 to 10 minutes to do 6 to 8.